Hi class, welcome to Module 3 of our Math Made Easy online course. At the end of the module, you should be able to define, identify, and illustrate parts of a circle, the center, radius, diameter, interior and exterior, chord, arc, central angle, and inscribed angle. Derive the relation among chords, arcs, central angles, and inscribed angles. State theorems relating chords, arcs, central angles, and inscribed angles. Define secant and tangent lines and segments, segment and sector of a circle. State and prove theorems on secant and tangent lines and segments, and solve problems that involve parts of circles. A circle is defined as the set of all points in a plane that are equidistant to a fixed point. The fixed point is called the center of the circle. The distance between each point on the circle and the center is called the radius. The length around the circle is called its circumference. Let us now define the other parts of the circle. The diameter is a line segment passing through the center of the circle and whose endpoints are points on the circle. We may also think of the diameter as two radii of the circle forming a straight line. So the length of the diameter is equal to twice the radius. A circle has interior and exterior regions. Obviously, the region inside the circle is called the interior, and the region outside the circle is its exterior. A line segment through the interior of the circle with endpoints of the circle is called a chord. The diameter is actually a chord that passes through the center of the circle, and it is considered as the longest chord. The angle formed by two radii of the circle is called a central angle. The angle whose sides are chords of the circle and vertex a point on the circle is called an inscribed angle. An arc is a portion of a circle. An intercepted arc is an arc formed by either a central angle or an inscribed angle. Now that you are familiar with the different parts of a circle, let us now look into the relations among these parts. Let's start with the central angle and its intercepted arc. In the given figure, theta is the central angle and arc AB is the intercepted arc. We sometimes say theta is the angle subtended by the arc AB. The degree measure of arc AB is equal to the degree measure of the central angle that intercepts the arc. If theta is an inscribed angle, then the degree measure of its intercepted arc is 1/2 the degree measure of theta. Based on the previous definitions, the following theorem applies. The angle theta subtended at the center of a circle by an arc is twice the size of the angle on the circumference subtended by the same arc. In other words, the measure of the central angle is twice the measure of the inscribed angle subtended by the same arc. This is often referred to as the inscribed angle theorem. Another theorem about inscribed angles is stated as inscribed angles that intercept the same arc are congruent. Let's consider some examples. Example 1. Determine the measure of angle POR in the figure.